Hello students, in this video we will cover some more examples of partial differentiation in context of homogeneous functions. Let's start with the definition first. What is homogeneous function? Consider function z of x and y. Then z is said to be homogeneous function if z can be expressed as x raised to power n f of y by x and n is called degree of z. For example, let's have a look at a function z and it's defined like this: x square plus xy plus y square. Now this is a function z. We say this function is homogeneous if the degree of each term in this expression is same. अगर सभी की जो डिग्री है वो सेम हो जाए हर टर्म की, then we say this function is homogeneous. Like if you look at the first term, degree 2, look at the second term, the combined degree, x has power 1, y has power 1, so combined degree again 2, and degree of y is also, the third term is 2. So we can say this function is homogeneous and degree is 2. But if we come across a second scenario, something like x square plus y square upon x minus y. Now again, if you see, the degree in the numerator is 2 and the degree of denominator is 1. So obviously this function is also homogeneous. But what about its degree? How to justify that? So for that, what we do, we try to convert this function in the form of x raised to power n f of y by x. For that, what I will do, I will take the maximum power outside, like x square. Then what's left behind? 1 plus y square upon x square divided by x outside, 1 minus y upon x. Now this is x square upon x, means simply x. Now whatever expression is left behind, if you look at that, the powers of x and y are still same. It's y square upon x square and y upon x. So I can write it like f of y by x. If you want to move that function in the form of f of y by x, remember that the power of y and x should be same. Now this is expressed in this form, so this function is also homogeneous with the degree of z is equals to 1 and it is not restricted to two variables only. ये ज़रूरी नहीं है कि जो आपका फंक्शन है उसमें 2 ही वेरिएबल्स हो. इट कैन बी extended in 3 variables, 4 variables. The same definition is applied to any such cases. We are just taking the reference of 2 variables. For example, you can also consider a function like z, which is defined as u square plus u into v plus w square divided by u cube plus uv square plus v into w v square w. Let's say like this. Now this is a function u expressed in terms of u, v and w. So again, what I will do, I will take the maximum power outside and you can choose any one variable. We can choose u, we can choose w, or we can choose v. We can choose any one out of u, v or w. That's totally our choice. So I'm going to take u square common from numerator. 1 plus v upon u plus w square upon u square divided by u cube common, 1 plus v square upon u square plus v square w upon u cube. Now this is u square upon u, so simply u raised to power minus 1 in the bracket. What I got, 1 plus v upon u w upon u whole square, 1 plus v upon u whole square. Now here in this last term I will split u cube. Since it's v square, I will write u square upon v square and w upon u like this, because ultimately it's again u cube. Split कर दिया हमने. Now I can write it like u raised to power minus 1 function of v by u, function of v by u comma w by u. Then this z is homogeneous function with degree minus 1. I hope it's clear now. the definition of homogeneous function. Let's look at some more examples. Now have a look at this. Z is equals to x cube y cube upon x raised to power 3 plus y raised to power 3. Now if you look at the numerator, the overall power is 6 here. So I am going to take x raised to power 6 common, y cube upon x cube. From denominator, taking x cube common, I got x cube into 1 plus y cube upon x cube, x raised to power 6 upon x raised to power 3 x cube, and inside the function can be written as f of y upon x. As per the definition, this z is homogeneous function, and how much is the degree? Degree is equals to 3. Next example, z is equals to x square plus y upon x minus y. One way you can also just simply see the power of y is 1 here, which simply states that this function is never going to be homogeneous. And if you want to check it by definition, then still I will take maximum power x square outside. From denominator we can take x common, and if you observe at this term is not having the criteria, this term is not qualifying the criteria of being expressed as x raised to power n f of y by x. यहाँ पे देखो क्या लिख रखा है, y upon x square, and what we were saying that the function should be in the form of y upon x, that is the powers of y and x should be same. यहाँ पे पावर सेम नहीं है. दिस इज y raised to power 1 upon x square, and due to this term this function is non homogeneous. तो ये फंक्शन हमारे पास होमोजीनियस नहीं है. सो दिस वाज ऑल अबाउट द डेफिनेशन. नाउ वी हैव अ रिजल्ट विच इज नोन एज Euler's theorem of homogeneous function, which states that if z is a homogeneous function of x and y with degree n, then the theorem states that x times curl z by curl x plus y times curl z by curl y is equals to nz. कि अगर कोई भी फंक्शन z होमोजीनियस दे रखा है, देन वो फंक्शन इस इक्वेशन को सेटिस्फाई करेगा. Now let's first prove this theorem, then we will see how we can imply this theorem to solve the numericals of partial differentiation. So let's start with the proof now. So given z is homogeneous function of degree n, so by definition z can be expressed as x raised to power n function of y upon x, equation number 1. Now I will differentiate this equation partially with respect to x and y, then curl z by curl x. To solve that, we will apply product rule here. First function as it is, x raised to power n, derivative of second function, that is derivative of this function f. Derivative of f will be f dash y upon x. Along with that, derivative of this angle, y is constant, and derivative of 1 by x is minus 1 by x square. Remember, derivative of 1 by x is minus 1 by x square, plus second function as it is, derivative of first one, that is n x raised to power n minus 1. Now the first term can be written like minus x raised to power, what we can write, this is n, and in denominator it's 2, n minus 2, then y f dash y upon x plus n. I am just reordering the terms, x raised to n minus 1 f of y by x. Similarly, we can go for curl z by curl y. Now see, from equation 1, now I am going to differentiate with respect to y. This term x raised to power n is constant for y, na? So there is no need to apply product rule. Constant term as it is, derivative of f is f dash y upon x, derivative of the angle, x is the constant one here, and derivative of y is 1. Now I will consider my left hand side of the equation. Consider left hand side, that is x curl z by curl x plus y curl z by curl y. This is equals to x. Substitute the values here. Just put the values of the differentiated terms in this equation, and here also what we can write it, x raised to power n, and this was x raised to power n minus 1 f dash y upon x to n minus 1 f dash y upon x. Now multiplying x and y inside. Now if we are going to multiply this x inside with this bracket, the power is here n minus 2, 1 is here, so ultimately total power is n minus 2 plus 1. N minus 2 plus 1 means n minus 1, so it's negative of x raised to power n minus 1 y f dash y upon x plus n. How much is the power here? N minus 1, and outside x raised to power 1 is there. When you are going to multiply n minus 1 plus 1, that is n. Base same, powers get added. Know this rule? यहाँ पे x की पावर कितनी है? n माइनस 1. बाहर आप x मल्टीप्लाई करोगे तो n माइनस 1 प्लस 1 कितना रह जाएगा? सिंपली n. सो x रेज टू पावर n f ऑफ y अपॉन x प्लस x रेज टू n माइनस 1 y f dash y upon x. Look at the first term and the third term. Exactly same with opposite signs. Cancel out n x raised to power n f of y upon x. Now what is this value? Equation number 1. Recall the equation number 1. X raised to power n f of y by x was z. So substituting this value here, I got nz using equation number 1, and this is the right hand side of our equation. That is, by Euler's theorem, x times curl z by curl x, y times curl z by curl y is equals to nz. So this was all about Euler's theorem. Now we will see how this Euler's theorem is helpful in solving the problems of partial differentiation. Let's have a look at this example. So this example is, if z is equals to x cube plus y cube divided by root x minus root y, find the value of x curl z by curl x plus y curl z by curl y. So हमें यहाँ पे एक फंक्शन दे रखा है z, and they are asking us to calculate this equation na, x curl z by curl x plus y curl z by curl y. Now if you are not aware of the concept of homogeneous function, what you will do? You will solve x curl z by curl x. You are going to differentiate this first equation with respect to x. You are going to differentiate this equation with respect to y. Then you will put the values and you will try to get your आंसर. ऐसे ही होगा. अब डेरिवेटिव्स को सॉल्व करोगे, सॉल्व करके आप इस इक्वेशन में वैल्यूज पुट करके उसमें अपना आंसर डिड्यूस करोगे. नाउ यू कैन सी टू फाइंड द डेरिवेटिव ऑफ दिस इक्वेशन 1 इज नॉट अ इजी टास्क. इट्स लिटिल बिट टेडिशियस ना, थोड़ा सा कॉम्प्लिकेटेड हो जाएगा ये. बट रादर देन दैट, इफ we can make use of the concept of homogeneous function, you will see you will not find it to be worthy to calculate the partial differentiation. आपको डेरिवेटिव निकालने की ज़रूरत ही नहीं पड़ेगी. बिना डेरिवेटिव सॉल्व करे ही हम ये पार्शियल डिफरेंशियल इक्वेशन की जो इक्वेशन में दे रखी है उसकी वैल्यू सॉल्व कर सकते हैं. सी हाउ वी कैन डू दैट. गिवन z is this function. So if this function z is going to be non-homogeneous, then that's a different thing. But if this function comes out to be homogeneous, then it is going to reduce our task. So first I will check if this is homogeneous or not and try to find out its degree, taking x cube common. And you can check whether the function is homogeneous or not by just looking at the powers of term. If I just look at here, it's x cube and y cube, same powers. Denominator root x root y, same power. So this is homogeneous. I am doing this way just to calculate the degree. So this is x raised to power 3 and this is root x. So it's 3 minus 1 by 2, and whatever is left inside I will just compress it in the form f of y by x, x raised to power 3 minus 1 by 2. So how much we get here? 5 by 2 f of y upon x. So this means this z function is homogeneous with degree is equals to 5 by 2. Now if its degree is 5 by 2, what does Euler's theorem states? Euler's theorem says that x times curl z by curl x, y times curl z by curl y is equals to nz, which is equals to 5 by 2 times of z. that is x curl z by curl x plus y times curl z by curl y is equals to 5 by 2 times of z. So I got my answer. They were simply asking for its value na, and I got my answer that its answer is going to be 5 by 2 z. And you can also cross verify this answer by first solving the differentiation, putting the value in this equation, and you will see you are ultimately going to have this answer only. But see, by using the concept of homogeneous functions, we saved our time, that rather than solving the differentiation, we can just check whether the function is homogeneous or not, and if the function is homogeneous, that's a good thing for us, and we can use the concept of Euler's theorem. Now we will solve one more example of partial differentiation, that too of second order, again using the concept of Euler's theorem. Consider this example. We are given a function u which is tan inverse y square upon x, and then we have to prove this equation of second order na? So let's start with the solution. We have u is equals to tan inverse y square upon x. Before checking whether this function is homogeneous or not, we have to get rid of this trigonometric function. पहले इस tan inverse को हमें खत्म करना होगा. So what we can do, we can shift this tan function to the other side. So you get tan u is equals to y square upon x. Now I can assume, let's say z is equals to tan of u, which implies z is equals to y square upon x. Now I can simply check whether this function z is homogeneous or not, because otherwise it was not possible to directly check the definition of homogeneous functions because of this tan inverse function. Multiplying and divide by x, I got x into y square upon x square. So it can be written like x raised to power n, means x raised to power 1 f of y by x. So this means z is homogeneous function with how much degree? Degree is equals to 1. Then what does Euler's theorem states? Euler's theorem says, as per Euler's theorem, x times curl z by curl x plus y times curl z by curl y is equals to nz, means 1 into z, that is z. And remember, we are applying the theorem on z, not the u. अभी हम u पे काम नहीं कर रहे हैं, हम z के साथ डील कर रहे हैं. Now we will convert this function z back to u, because z was assumed by ourselves ना, हमने z पुट करा था, लेकिन हमें जो इक्वेशन चाहिए वो किसकी टर्म्स में चाहिए? u की टर्म्स में चाहिए. Now from equation number 1, what will be curl z by curl x? Derivative of tan is secant square u, curl u by curl x. Similarly, curl z by curl y is secant square u, curl u by curl y. Let's put the values of all the terms of z in equation number 2. What you will get? X times secant square u, curl u by curl x, plus y times secant square u, curl u by curl y, and the value of z was tan of u. Taking secant square u common, x times curl u by curl x, y times curl u by curl y is equals to tan u. Shifting secant to right side, we can write it like tan of u upon secant square u. Let's try to simplify this right hand side now. Tan can be written like sine upon cos, and what is the secant square function? Reciprocal of cos function, yes. So it can be written like cos square u. One cos is getting cancelled out, so this is sine u into cos of u. Again, little bit of more simplification, multiplying and divide by 2. You know this trigonometric identity na? 2 sine u cos u is sine of 2u divided by 2. So I got x times curl u by curl x, y times curl u by curl y is half of sine 2u. So my one part is done, that I have deduced the first order equation. Now I have to deduce the second order equation. For that, what I will do, I will differentiate this equation with respect to x once and then with respect to y to get the second order equation. एक बार डेरिवेटिव हो चुका है ना इसमें x के साथ और y के साथ. अब इस इक्वेशन को हम क्या करेंगे, एक बार डेरिवेटिव करेंगे, एक बार और x के साथ एंड देन फिर उसके बाद y के साथ. लेट्स डू दैट. डिफरेंशिएटिंग इक्वेशन 3 partially with respect to x. So let's write that equation here. The equation was x curl u by curl x, y curl u by curl y, half of sine 2u. This was the equation and we need to differentiate this. Now I am differentiating with respect to x here. So product rule will be applied on the terms of x now, because there are two terms multiplied here. First term as it is, derivative of second term. So it will be second order derivative plus second term as it is, derivative of first, that is derivative of x, which is simply 1, plus, remember there is no need to apply product rule here because this y is constant, let it be, and derivative of this term will be, it's already differentiated with respect to y, now we need to differentiate it with respect to x, like this, equals to half of derivative of sine cos 2u, along with that derivative of this angle 2 into curl u by curl x. Let's do the simplification. This 2 is getting cancelled out here, shifting this term to right side, because on left side I will consider only the terms of second order derivative, x curl square u by curl x square plus y curl square u by curl x curl y is equals to cos of 2u curl u by curl x minus curl u by curl x. ये टर्म कहाँ से आई? From here. You can take curl u by curl x common, cos 2u minus 1 curl u by curl x. Now multiply this equation by x, and why we are doing so, because it was required in our problem. जो हमारे क्वेश्चन में इक्वेशन दे रखी है, that contains x square. So we will multiply this equation by x both sides. So you get x square curl square u by curl x square xy curl square u curl x curl y cos 2u minus 1, the x which by which we have multiplied the equation like this. Now you have to repeat the same steps in context of y, like differentiate that equation 3 partially with respect to y, do the necessary simplification and multiply then by y. Repeating the same process for y, you will get fifth equation, which I am going to write here, and you can cross verify your answer after solving that. You will get y square curl square u by curl y square. I am not doing nothing new, I am just observing the pattern. You can also write it directly if you want to, but if you are solving it for the exam, you need to show it step by step solution. So instead of x, now I am just replacing that x by y. xy curl square u curl x curl y cos 2u minus 1 y curl u by curl y, equation number 5. Now just to get the desired result, add number 4 and number 5. फोर्थ और फिफ्थ इक्वेशन को अब हम ऐड कर देंगे. In the left side you will get the desired equation, and how I got 2 here, because these two equation terms are exactly same, so when you are going to add them, it will get 2 times equals to, on right side, see this term is common na? Cos 2u minus 1, so I am going to write it once, x curl u by curl x plus y curl u by curl y, and what is the value? We already reduced it using Euler theorem, half of sine 2u, equation number 3. Cos 2u minus 1 into half of sine 2u. Trigonometric identity. If you recall the formula, what is the formula of cos 2 theta? It is 2 cos square theta minus 1, and it's also 1 minus 2 sine square theta. Since if you look at the problem, they are asking us to prove the answer in terms of sine function only, so I'm going to use the second formula. From here I will reduce the value, but you get here cos 2 theta minus 1 is equals to minus 2 sin square theta. So same thing will be applicable here. Minus 2 sin square u, 1 by 2 sin 2u, 2 is getting cancelled out. So minus sin of 2u into sin square u. This was the right hand side they were asking for. Hence proved. So you can see how we used the concept of homogeneous functions to prove this equation. Otherwise, if we are not going to use that part, it will be very complicated to find out the double derivatives of this term and then to solve the left hand side of this equation. I am not saying we can't solve that. We can solve, but it will be little bit complicated. And to make the problem simplified, we use the concept of homogeneous functions. Now you can give a try to this function, that if u is e raised to power x square plus y square, try to find out the value of x curl u by curl x plus y curl u by curl y. Rest, if there is any problem, you can let me know. We can discuss that in our next video. Thank you.